So your withdrawal procedure is very simple. First of all, we already talked about it in lecture 1 here. Everyone is entitled to 1 unsubmission per semester. Okay, so make sure you want to use it because it's only 1 for 7 assignments. And if you really want to use it, email your TA, not me, or not Prof. Gu, or not Prof. Henry, okay? Email your TA. Your TA will do it for you, okay? If you email me, I may be able to do it for you, but you may wait for a bit delay because we have 800 students in this class. Is it okay? Yeah, so you can do that. How can we check the grade for each assignment? They will be on cosmology. After your TA marked, your grade will appear there. For assignment without importing outside into math, you may need to do the import later, okay? So this one, you can ask the tutor how exactly this is happening. Why does flow 10 plus 2 produce an error? Because it's not a number. So if you want to compute 10 plus 2 as a string, actually Python has another function called eval. EVAL, okay? That's quite a useful cheating function. Okay, so you can do that, but there's not very so-called legit for the first half of the semester. So try to understand this unit eval instead of just float. Do you need to write all the expression within one line? Yes, you do. Actually, the expression is quite simple. Yeah, so you need to write all the expression with one line. If you really is long, then maybe something wrong with your expression, okay? So you don't really have to. Okay, enough warm up. Shall we start? How do I? Okay. Okay, let's start. Ready? Can I ask everybody to try to be a bit quiet because I will be more distracted if this is like that. Okay. If your friends around you is still talking, you can ask him quietly too. Yeah, okay. Just thank you. Let's start. Would like to ask you quiet because today is quite important. We start to have some real programming logic. And this is, I would say, if you don't understand this, you have a very hard time in the following code because all of your programming, and actually I would say all of your following engineering, whatever curriculum, even your life is depending on that. Really, okay? So let's see. I hope you remember how to solve a quadratic equation. Anyone forgot already? You remember this in your high school or primary school? Or not primary school, I think. Remember that? So what is the question? The question is, I give you a formula a squared, some x squared plus some x plus some 3 equal to 0, and you need to solve and compute the x for it. Okay, find your x again. And usually the question goes like this, right? I will give you the number a, the number b, and the number c. And now the question is, what is the x or x's that can satisfy this equation? I'm not going to prove all. If you recap, you have some formula like this. Is it okay? You know what is the good thing about computer science or engineering? Let's don't care about how it's proved yet, okay? Let's just use the formula. So a lot of time, if you want to implement something, you can just Wikipedia or Google the formula and try to fit it in and see it works. So anyone remember this? Okay, so let's try to implement it and use it to solve quadratic equation in Python. However, this is what it's supposed to be. Okay, so I wrote a function like last time. We talked about the function encapsulation, that the three inputs will be the three number A, B, and C. Then start compute, okay? Is that very complicated? Do we have some time to digest? First of all, what is this guy? Go back to the formula. This is this one, right? How do you express B squared minus 4AC? B squared minus 4AC, you need to write it like this. Okay, sorry. So here, this line, right? This line is a delta. B to power 2, and then minus. Can I write 4AC? Cannot, right? Because you need to tell the computer that, the Python, that you have to multiply them. So you have to say B squared minus 4 times A times C. And then what is the answer? Because you know there's two answers, right? One is minus B plus that square root, and one is minus C minus that square root. But wait a minute, where does this square root coming from? If you just run the code, it will have an error. Why? Because you need to so-called import the square root. Square root function is not a default built-in Python function. This has been a bit mentioned in your tutorial. And suppose if you import the square root function, you can run the code, because after computing answer 1 and answer 2, then you just print out the answer 1 and answer 2, right? In Python, you have a lot of other packages. I don't know anyone heard of like NumPy or Panda, yeah, and so on, right? So those are all the packages. What does that mean? Python language alone is a simple, powerful language, but it cannot load in all the functions at one time. So whenever you need to use some function, you need to import it. This is actually a very common phenomenon for many languages like C. C is called library, and Python is called package, okay? So I'm not going too deep into it, but what you can do is, you can just go and check the Python document, and here there's something called library reference. You can just import the library as you want to use a lot of amazing functions. The function is like all being there. You can use whatever you think about it. I know that in engineering, you have a lot of functions, right? Like a Gaussian, whatever, very cheap naming, I cannot even pronounce function, right? They are all in those Python library. You can just ask it for computing it. And when you click in the reference, it will tell you how do you use those functions, okay? So those, but it's not that we are not talking about it, but we don't talk about it now. The way to import it is you can say from math. Math is a library. The library can be other library, like NumPy, like Panda, those library. And then you can import one or several functions or constant from there. Then you can directly use it, okay? So if you import correctly, you will have the following output. So the expression is just a bit complicated, but if you can formulate the assignment 1, you should be able to catch it up. Okay, why is it a red word? Can someone tell me? I thought I implement everything right. Why? Why I try to solve if A is equal to 1, B is equal to 1, and C is equal to 8, why is it wrong? Yeah, there's a negative value in the delta, right? Yeah, thank you. There's a negative value in delta because if you solve this one, what if the delta is negative? Is it reminding you of your secondary school math? Okay, I hope you didn't forget those. Yeah, so if you solve the normal equation that you can be solved, B squared minus 4AC, B is 5, 5 squared is 5, 5 minus 4 times 6 is 24, so it's 1, so it's positive, you can square root. But then, why is it create an error? because b squared is 1. B is 1, right? 1 squared is 1. 1 minus 4 times 1 times 8 equals to 32. And then it becomes negative 31, and I cannot do a square root. Okay, now, if you are the one who write this function, what will you do to make it better? Just let it crash. If anyone use my function crash, then crash. I don't care. Of course, you cannot. I mean, if you write a function like that, you cannot sell. Imagine an app in your phone like that. You enter something wrong, it just crash. You won't be able to get a popularity with your phone, with your apps. So we need to make a decision to know that whether we should proceed or not proceed before we compute the square root. So that's what we want to do. We make choice. What is the choice? It's very simple, right? If the delta is less than 0, you will tell the user, sorry, the root is imaginary. You want to try something else. Otherwise, you will proceed as what you want to continue. Then you just compute the right number. Okay, so we called it one of the control structure. Now I'm telling you 3 control structure that is actually basically most of the computer language is about. The 3 control structure one is, the first one is sequence. Sequence is quite simple. It just tells you a program will just run line by line. They will like computer instruction and it will go one by one. However, this is another second one. It's called branching or called decision making. That means if you do this, I will do A. If you do the other, I will do B. Okay. The third one is called repetition. That means I'm just going to repeat and repeat and repeat. And these are the 3 control structures usually used in most programming language. I will explain one by one. The first one is super simple, okay? So I just use 1 page. What is the first one? Very simple, sequence. I don't know anyone do any, like IKEA. Anyone use IKEA furniture? You do IKEA furniture, what do? You follow the instruction one by one. Although I'm usually the one who don't follow. I just do it, right? But if you follow the instruction like a recipe, how do you make a cake? How do you make the turkey for Christmas? You want to follow the instruction one by one. So this one is no brainers, okay? But it's the usual control structure of most language. And let's introduce what we want to talk about, the first topic about today, the branching, making decision, okay, A or B. Should I go to NUS or should I go to another university? Okay, should I take this job or this job? Should I get this boyfriend, girlfriend, or the other boyfriend, girlfriend, okay? And so on. So usually the description, the decision is very easy. You usually will based on some condition, okay? And the very basic structure for most languages is if a certain question, or we call it condition, is true, I will do A. Otherwise, I will do B. For example, if I have more than $1 trillion, what do we do? I will buy a car, eat a lot of buffets, go travel, quit NUS. Okay. But if not, else, I don't have that much, right? What do you do? Okay, be good and study, okay? Let's study well. Of course, this is a very weak so-called example. What if you have $999.999 trillion? You still study, okay? But I just want to say that because of the condition, you will choose A or B. And one important issue here, whatever A or B can be complex or we call composite action. I can do a set of A things or can do a set of B things, right? For example, B, if I don't have that much money, I will be good and study and then later get a good job and then try to earn as much as money as possible, whatever, right? So I can have a set of instruction in both sections. And if it's a set of questions, I can think even more in a complex recursion version, like I can even put another if there. So if I have that much money, if I'm a heartless person, I would just do all this enjoying myself thing. Of course, if I have this much money, but I'm not a heartless person, I donate all my money to charity. Okay, yeah, like real. Okay, but of course, it's not really real, but you can see I can put even more complex structure within do A or do B. Of course, you can even do if, inside if, inside if, inside if. We call it a nested structure. It's called nested. Of course, another thing is, it's very, I would say what? It's amplified in computer science. What if you don't have an else? Okay? So for example, if today I say if NUS admit you, for example, you're not from Singapore, right? You come to Singapore lah. Then what if you are, let's say you are in another country, you're in another Asia country, or you're in Europe. What if NUS does not admit you? Then you do nothing now, because there's no else, okay? If you have else, you have other plan, it's okay. Then else I go to US, else I go to Europe, else I go to China, else I go to India. There's an else. Sometimes there's no else. So interestingly, in control structure, if there's no else, you do nothing and continue. Okay. So this is the overall so-called concept, but we want to talk about how Python is look like when you do this. This is how Python do, okay? I will explain the syntax later, but just want to give you an overall application of the control structure. Just now we talk about, we want to solve the quadratic equation. And the problem is, what if delta less than 0? So we want to make sure if delta bigger than 0, I do something. So delta not bigger than 0, I do other things. And if delta larger than 0, we call it a condition. Okay, it's not like you are going to the doctor and you are sick, you have a condition. It's not like that. But this condition is for you to tell whether it's true or not. Just one advanced note for that. The condition, you should have some chance to make it correct or not. That means according to different situation, like different values of A, B, and C, your program should have the freedom that the true is possible to happen and the false is possible to happen. Otherwise, you're just writing some useless code. Okay, what if the condition is true? Condition is true meaning delta is larger than 0, right? So you be good and compute the numbers. Okay, this is like a normal running of the code. So you compute the number and just proceed as normal. What if delta is less than 0? You cannot compute, right? So you don't want to get involved with the square root. Then you print, sorry, your equation have no real root. I just quit. Of course, if you are more advanced, you can try to do the complex solving, right? This some I, whatever, something plus something times I, those complex numbers. You can do that, okay? Python also have a package for the complex number, but let's stop there first, okay? So we just do this example. So the usual structure, if you want to simplify to the simplest, is this. I will if some types of expression. This expression we're going to evaluate into some values that can be true and false, and I will actually execute statement S or statement the other do A or do B. For example, this is an example, okay? I ask how old are you? You will import your name, right? Your age, sorry. And then I will say if your age is larger than or equal to 18, then you can drive. Otherwise, you cannot. So the whole Python syntax is very simple. You do if, and last time we talked about if is this a keyword. What color is it? Orange, right? Yeah. So you can see the color orange and the else are two keywords, and you put a condition. The condition is age larger than or equal to 18. Then you do the two things. And is the indentation just a decoration? No, right? Because you have to put the indentation to show that those are the code in the block. okay, in the if block. So anyone play around with my Visual Python? If you do any, if age is larger than 10, you print A, else you print B, right? So let's say, I just put a code. You can see the if blocks is one block that you have the decision making, including the condition, the yes answer, and the no answer. Okay. If you put some more internal block, it will be something like that. So if age is larger than 5, I do print A, else print C. Okay. So let's don't talk about the real meaning of, but do you see that you have a block? You need to train your eyes to visualize the blocky item like that. Later on, you have more blocks, so more blocks like loop blocks, function blocks. But can you see that? The if block is one block, you can actually add more items later or before. Like other words, in the whatever. Whatever it is, there are blocks that is created by the if block, and you can even insert more inside the green one or after the blue one. The first training you need to do in this coming tutorial is to visualize the box in your tutorial coming. Okay. And they're all governed by the indentations. Of course, we said that you can do it without the else. Okay, so can somebody tell me what will this code do? If I input 11. Anyone? Yes? Nothing, okay? If you input 11, this code will print nothing. Just go on, okay? So because there's no else and no action in the else. So that is a weird thing. If there's no action in the else, you just do nothing and pass to the next statement. Okay. And of course, you can put some if within another if. For example, this one is how old are you? If you are more than 18, I will ask you, do you have a car or not? So you answer me Y or N for the yes or no. If you Y, then you mean you are 18 in the same time. You also have a car, then you can drive now, right? So you can have this condition. But if you're only 18, but you do not have a car, so even you have a driving license, you cannot drive. Okay, so you can put more nested if inside. And the trick, this is a little good trick, I would say is a good invention in Python. Just now you put the if in the true block, which means when the condition is true. But when you put if in the else block, which means if the condition is false, Python will give you something to help you to reduce the clumsiness. For example, this one, if your age, I don't know whether you noticed it, in Singapore, we can drive only if more than 18 years old. But in US, it's not. US is 16. Okay, so that means if you're more than 18 years old, I can already say no matter where you are, you can drive. If you're not more than 18 years old, but then I can ask you, are you in US? In US, then you can drive, right? So of course, you need to be more than 16 years old, but that is more condition later. But if you're in US, then you can drive. So you can actually add the if even after the else. But what I want to say about the reduction of clumsiness is, these two, after the else, the if can be glued or fusion or merged together. You can do this. Do you see that? I can merge the else and the if together, become an elif. I don't know how to pronounce it. Elif, whatever it is, means elif. So you can merge them together. The function is totally the same. Is after else, you put an if. But why do we put that? Compare this code to the previous one. Every time you add an if, you have to indent one more. Then your code will be like very slender, like a triangle. But if you put this, they are more like parallel. Your code will look nicer. For example, I can put even more than one elif. Okay, elif. For example, this one, if a is equal to 4, so I first check whether the first elif is about. So if a is less than 0, I print yes. Is it true? No, right? How about the next one? The next one, I ask if a equals 0. Is it true? Still no. And then the third one is a is equal 4. Is it true? Now, yes. So the final output for this code is, okay. It's not her, okay? So the last one is like a wildcard else when everything fails. So this is like a gate you open, okay? Yeah, so you can actually think of the elif structure by the flowchart we introduced on the first lecture. But yeah, so each of the if is actually a division to ask you for decision. Okay? Any questions? Let's see. I would like everybody to take out your phone and try this. Okay, let's have a small ungraded quiz. Only 4 questions, okay? Please take out your phone. Maybe we can do a small understanding, see how much you got it from this lecture, okay? I'll give you a bit time, register. How many? Yeah. Let's see who is the fastest or the highest point in this. Okay, anyone still need some more time? Do I need to make the QR code bigger? Okay. We'll zoom in. Okay. Anyone need more time? Hold up your hand to log in. Okay. Otherwise, we start. Let's get 10 more seconds. Okay. Let's try. Anyone? Okay. Ready? Let's start. Conditional statement exercises. Okay. Don't worry, it's not graded. Okay. But it would be good if you put your name. So let's see who is the highest. Ready? What will the following code print? Okay. You have 20 seconds. This should be easy. Just a warm up first. Okay. Okay. Let's see. 20 seconds passed. It will print. You're okay. Okay. Who insists yourself is a bit fat still? Okay. So it's simple, right? Because if h is equal 7D, if it's not larger than 400, then you'll be okay. Okay. So how about next one? Wow. Good job. This is the reaction. Okay. Let's try this. What will it print? Okay. Hey, now, yeah, good job. You are not okay. Okay, there's no not okay there. But then it will be nothing because it doesn't have the else statement. So for this 1% here, you want to talk to me later? Jason, good job. Ready? Those two are warm-ups. What will it bring? Watch carefully, read carefully, okay? My mark is 80. Are you sure your answer is correct? Let's see. Why? Why? Ouch. Why? Why is it not? That's what I want. Because I tricked you, right? Why? Can someone explain why? The condition will be tried one by one from the top to the bottom. Okay? So that's why even though you have a third option, that my mark is exactly equal to 18, but too bad. You have a previous one that is more suitable. Okay? Who come first will finish it and then will not. One thing you need to notice is you will ignore all the else, no matter how suitable it is. Like getting a wife. You get the first suitable one, you get married, and then no matter later how good later it is, sorry, you have to focus on your marital, okay? So that is the same thing. So at least it's more than the next one, okay? Are you ready for the final challenge, okay? Let's see. Ready, yeah? Wow, still got it. Wow, solid. Ready? If I want to find the max number between A, B, and C, how do I fill up the code to do that? This is super fast, okay? Ready? Go. This is going to be hard, okay? This is because I know that I cannot change the time. Ha ha ha. Are you scared about your midterm? The answer is, whoa, still quite a lot of people got it right. Good job. 55% people get it right. You guys are fast. The fast is a good thing, okay? But I would say, to be fair, this is a hard question. It's not because it's hard. It's because I don't think I give you enough time, okay? 20 seconds for that is a bit, because I don't know how to tune this guy to be having different timing for different questions, okay? Maybe later I'll figure out. But then I'm still very glad that 55% of you got it right, okay? I'm expecting like 40 or something. But can you see why? So I think the first decision is because A and C printing is on the first loop and the first level of the else, which means this one. The first decision, you want to figure out A is the biggest. So you want to find something A is the biggest. So is the first line must be A is bigger than B or A is bigger than C. But I don't give you A is bigger than C. You can do that actually, but A is bigger than B. So the last two will be correct. And then the last one, of course, if you print B, will be B bigger than C, the last one. the third one, right? The last one have to be bigger than C. So the answer can be anything. So the second one, the middle one, I print A. I print A here. Of course, A bigger than C lah. Otherwise, I print C bigger than A, right? So you can determine the second one must be A bigger than C. So yeah, let's go to logic, okay? But don't worry, in midterm or final, we'll give you similar question, really, okay? But not that short. I think the average time for each multiple choice of this kind of question in midterm will be at least 1.5 minutes or 2 minutes, okay? Don't worry about too much about that. Yeah, this just because it's in lecture. Okay, that is a conditional statement. We'll continue a bit later, but before that, let's see this, whether you can remember what is conditional statement, okay? If then else, so the first case you fail, the second case you fail, still fail. Yeah, finally go to else. Okay. So if then else is like that. So if suddenly somewhere is open, then you can actually go through that. Okay, so it's if then else. So the else is like a wildcard. Okay. Okay, that's the first part of if then else. I will pause it a bit, see if there's any question. Why k equal true give false? Okay. Why k equal, what I mean? Oh. I think this one you are confused with. I talk about in lecture 2 or 1 that if anything that is not empty, we treat it as true. So yes, the letter K is treated as true only when you use it as a comparison value. I want to decide whether it's good or not. But K is not true. If you put equal sign, the left-hand side and the right-hand side, after they evaluate, they have to look the same. Okay? So they have to look the same. K does not look like true. Okay? Although both of them can use it as a conditional statement, I can say if the string of K then become a true value. Okay? So it does not. So K is not. So the equal sign is not only like a scale, but you actually examine if both of the sides are the same. This one is complicated, okay? And to be honest, just before we do that, I want to say that it won't give so-called, I won't give this kind of question. So the simple logic is, if for normal modulo, right? Normal modulo, what do you do? A normal modulo. But anyway, it's not related to condition, but I would like to answer. If it's normal modulo, what do you do? So it's 11 modulo 4. What do you do? Of course, you say I divide and whatever, but you can think of a bit like that. 11 minus 4. 11 minus 4 again, until before I finish minoring, okay? So that one, you can also treat the same. What is 5? But 5 cannot minus 3, right? You can choose 0 minus 3. That's 3. And 0 minus 3 again becomes 6. That's why exceeding 5, it becomes negative 2. So this one is you can treat as 0 plus 4. And 0 plus 4 again, and until it becomes reaching 11. So that is a bit weird, okay? And I also encourage don't do this in your programming. Yeah, we have all this very weird construct because it's there. But however, this kind of thing is into a very programming language level, okay? There's even more weird thing later I will show you in the sequence, whatever. Let's don't go there first, okay? So I just promise you in exam, I won't test you for a negative number, okay? So we have a 5 minutes break. We'll continue on the repetition, okay? In the meanwhile, let's see, because the repetition is a bit longer. So we section these two sections to be one shorter and longer, okay? So we'll see you in 5 minutes. Yeah, so actually this is a very good movie, okay? For those people, at least you want to be a nerd and geek, but together with very handsome and stylish. Please go and watch it, okay? So very good. It's called 21. The novel is called Bring Down the House. It's a real incident. How these people use math to beat the casino system. They didn't cheat. It's not like the Hong Kong gambler movie. It's not like they change card, whatever. It's not like that. It's not like superpower. They really use math to beat the system, okay? It's a real historical event. Okay. Just now for the questions, if you got one or two right, good. You can actually already do some simple conditional statement. If you got your question 3 right, you are quite mature already. You should be able to go some nested statement. For the 55% people, congratulations, you probably get an A at least, okay? But you can do this complicated logics. Logic is one of the most important thing in programming, okay? Congratulations on that. And for your homework, I think it's in homework 2 or 3, I don't remember that. That's not the only condition you will consider. Can you figure out any other condition that will crash the program? Up to you, okay? Don't say out. Think about that. There's other thing than crash the program, and assignment 3 or 4, I forgot, 3 or 2, that is going to ask you to try to do other conditions right in order to make it fail-proof. Okay, the other, remember what is the free control structure? The sequence, this conditional statement, which is selection and repetition. What is repetition? Repetition is like my mom nagging you every day. Make your bed, make your bed, make your bed. Drink water, drink water, drink water, drink water, drink water. Until you make your bed and drink water, right? So that is your repetition. Remember we talked about the bingo game in the first lecture? So of course you do all the condition to give prizes, but overall you need to loop it. That means one customer come, I will do a lot of procedure to let the customer play and give him prize, but I will repeat. So repeat until when? Repeat until maybe the sun go down, or I no more customers, or my prices come out. So repetition is one of the important things we can let the computer do, because humans don't want to do it. For example, a very simple condition. This, you can see that a lot of people will be confused with if then else. Because it's too much like if then else. While I'm hungry, eat a bun. Is it like if then else? If I'm hungry, eat a bun. What is the difference? That means if I'm hungry, if I use if I'm hungry, eat a bun, after I ate a bun, what happened? My life go on, right? I continue to do things. But what is the difference of this? After you eat a bun, remember this, you go and check if you're hungry again. Is it okay? Then you eat a bun again. Is it done? No. You go and check if you're hungry again. So this is a loop. That means it is very similar to if then else. If I am hungry, I eat a bun. But if you successfully satisfy the condition and eat a bun, you will repeat. Until when? Until the condition is not true. That means if I'm not hungry. Okay? So, for example, this another one, like the if then else statement, I can do a nested while. While I have money in the bank, I take out the money from the bank, and while I have money in my wallet, I go shopping. Okay? And then I can keep doing this while I'm still have money, I go shopping. Until when? Until I have no money in my wallet, what do? I go and check if I have money in the bank. If I still have money in the bank, I will go do the all loops again. Okay, so can do as many nested loop as possible. In computer science, we call it iterations. Okay, it's just meaning you want to repeat something until some result is satisfied. And well, but usually it's very simple definition, but I would like to tie it up with the usual application of repetition, because I think this is one of the things I find out for a lot of years, students will think about the repetition in these three ways are better. So what is the three ways? There are three ways of repeating things. One is, I know I will repeat n times when I start looping. The second one is, I don't know how many times I loop. I just loop until something happens. The third one is in between that, it means I may run n time, but I know that at most n time. I will try to talk about these three different loops. First is, remember these three we talked about in last lecture, is it? I try to encapsulate the triangle to become a function to draw a triangle. However, you see here, I know that I want to draw these 4 layers of Christmas tree. It's going to draw 4 times. So I know it. And what happened? I can use loop. And the first thing in Python is, if you know how many times you want to loop, you want to change it to a for loop. Okay? For I in range 0 to 4, I do the drawing. I will explain what is this for I, whatever things, but it means anything within the indentation again, indentation, I will loop 4 times. But why is 0 to 4? Okay, so let's try to understand what is it. The usual statement is for I. Actually, the I, you can change it to a variable. You can change it A, you can change it counter, you can change it J, okay? The I is any variable you want to change it. But if you're lazy like me, you want to call it I. And the range is start to stop. Okay, for example, I can do for range 0 to 5. That means I start from 0, stop at 5. Will I print 5? Will I print 5? I said 0 to 5. Will I print 5? Does it ring a bell of what we did before? The string slicing, the exclusiveness. The start is n. The stop is m. But as what we talked about string slicing last week, we will start from n until m, but excluding m, right? So that's why you can see it here. I will repeat the print statement. And you can also see that the variable I will change within the loop. The first time, I is equal to 0. The second time, 1. The third time, 2. Until 4. Will I do 5? No. It's the same rules for the string slicing, right? The slicing also excluding the last number. So I can loop this as many times. If I want to loop 10 times, I can say 0 to 10. If I want to loop 100 times, I can do 0 to 100. Let's try to put it in application. I hope you remember what factorial, okay? Factorial n means 1 times 2 times 3 times 4 times 5 all the way to n. And the usual thing, how do you transform into a program is, in real life, how do you do it? Punch the calculator lah? No. I mean, if I give you paper and pencil, how do you do it? You want to multiply 1 to n, right? So first you multiply 1 to 1. That is easy lah, okay? And then 1 to 2, right? And then 2 times 3 equals 6. And then 3 times 4 equals 24, and so on, right? But pause there. I want you to concentrate on the screen. There are two variables. One is called product. The product is containing the product so far. The counter is running 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want you to concentrate. And let's redo again. From the beginning, what is that? From the beginning, product is equal to 1. And my counter is equal to 1. And I do multiply them and store it in the product. Okay, the important thing, I will store it in the product. There's a temporary solution. And then 3, I will store it into the product. 4, I will store it into the product. The temporary result of the factorial, I will store it into the product. Sometimes we call it the accumulator. Okay, you hear me say the accumulator. The accumulator is like the temporary answer when your program is progressing. I accumulate whatever it is in the accumulator. And the next thing is 5. And if I want to multiply, so computationally, I can transform that idea into pseudocode. I was first saying that, oh, the product at the beginning is 1, the counter is 1, and I will repeat this. Each time I will say, I will replace the product by product times counter. But I will increase the counter every time. If you use for loop, the last line is not necessary, right? Because the counter will jump for yourself. That's what the for loop do. Later, we'll introduce while loop that you need to manually increase the counter. But if you use for loop, wow, so good. The counter can fit into the for loop infrastructure nicely. After you're finishing looping the number of time, the remaining value in the product will be your answer. Okay, so let's see. This repetition, what exactly is doing. So I give you the real Python code. So now I write a function called factorial, and the input parameter is n. Nothing real new, right? Product is equal to 1. That's what we said. And now I want to loop the counter from 2 to n plus 1. Why is it not 1 to n plus 1 or 0 to n plus 1 or n? Can I start the range with 1? I ask you later, okay? Let's continue first. Then I do product is equal to product. It's the same as just now the code, right? Actually, it's nothing changed, just change it to Python format. And that's it. 4 lines of code. I mean, usually I say 4 lines of code is excluding the header. That is the factorial function. Okay? And let's try. What if I want to do factorial 6? In the beginning, product is equal to 1, and the starting value of the counter is 2, right? Because I start range 2. And 2 times 1, I will do 2 into the product. And the next time, counter will jump to 3 because it's a for loop. And now 3 times 2, I will put 6 into the product. And then the counter will jump to 4. And then 4 will times 6. 6 is actually originally is 1 times 2 times 3. 6. And then next, will I continue? No, the loop will not continue because it's up to n plus 1. N plus 1 will stop. It won't get into the body. And then the final answer is 120. Okay. So you can see that the accumulated answer is temporarily stored in the product variable as an accumulator. So the usual syntax for loop is for a variable, the variable can be any variable you name. One of the culture is if you really don't need that variable, usually people will just put underscore. So for underscore in range, whatever. Yeah, which is a lazy variable because they don't want to declare that. And what is the sequence? This is complicated, okay? But now you only know it's a range. Later you learn other things. The sequence is like a range. The range also start, stop, step. The same rule for the string slicing in the last lecture applies. You can still do the same manner or the logic between start, stop, step, okay? And it will create the sequence of integers. And finally, the body is whatever you do inside, okay? You can do a lot of statements. It's like, I hope you didn't get the wrong idea. You can also do a lot of statements after the indentation, okay? And for example, one thing for the start, stop step, you can do some lazy notation. If you only put one number, Python will treat it as a stop. It will set the default as a 0. Okay, so this is the same as 0 to 10. So how many lines will we print? 10, right? Thank you. 10. And the I will be ranging from 0, 1, 2, 3, 4, all the way to 9 without 10. Thank you. Of course, you don't need to start with 0. You can start with other numbers. So for this one, we'll print 6, 7, 8, 9. Okay, this one, because it starts with 6 and ends with the number before 10. Okay, I've talked enough. How about this? You tell me. How many numbers first? How many numbers will we print? 2, right? Thank you, thank you. Thank you for the fingers. 2, right? Which 2 numbers? Of course, 3 lah, okay? What's the next number? 7, thank you. So 7, 3 and 7. And that's it. The next number is 11. 11 is already out of range. So it won't be printed, okay? And let's put it in use, okay? As I said, sometimes, yeah, I want to be good in math and know a lot of things, but sometimes you don't, okay? You just want to do experiment. What do you mean by if you want to flip a coin, if it's fair? Fair means if I flip a coin, I want to think that the head and the tail is 50-50 chance. Is that true? Are you sure? How do you prove it? How do you know it's true? You examine a coin, the coin is not symmetric. The head or the tail, maybe there are different weights. Whatever it is, it may not be true, it's 50-50%. Why I want to mention that is because, you know, in Singapore, we have casino now. There's actually an accreditation society. Make sure your tools are fair. What does that mean? If you roll a dice, is it true that every single number is 1/6 chance? Theoretically, you believe so, but too bad it's only your belief. I don't know. So for real casino, actually we have went through a credential process. You need to test the dice. Is it really 1/6 chance per number or close to 1/6 chance per number? You watch those movies, right? Those gambling movies from Hong Kong, whatever, right? Those dice can be bias or inside mercury, whatever tricks that you can actually throw the dice to whatever you want. But they want to make sure the one in casino is there. But the next question, now the casino is all digital. The slot machine is digital. How do I make sure those random numbers are random? Why is it not the casino actually always put out the number you cannot get the jackpot? How? I don't know anyone play those games on iPhone or whatever, draw cards. You know there's a new rule in Apple that they need to tell you the percentage or the probability of drawing certain card or item you want. How do you guarantee that? So a lot of time you need to prove your number generator is correct. So how do I do? Let's go down to a simple one. How do I prove that the chance of flipping a head and tails are 50-50? Let's say you want to write an app for that. And there are people who will put $1 billion in gambling in your app. So you better make sure your chance is 50-50. How? The very traditional way is, let's flip many times. Okay, I do experiment. I just try to do it a lot of time and see is it really biased or not biased. So what I will do is I will flip the coin 1,000 times and record how many times it head and how many times are tails to prove your system is working correctly. And if I want to test it in your Python program, how? I record the number of heads, right? So it's a very simple program, okay? I call this flip coins. What I will do is I will loop it 1,000 times. Actually, if you want, you can loop it 10,000 times or 1 billion times. And then what I'll do here is, this is the random number generator, this one. This function is from the package random. So I introduce another package again. The random package will give you all the random thing you want. But what random thing you want? This one, I want random integers. There are other random like floating point number, okay? But this one, I want integers. So this random in actually will generate either a 0 or 1. So it's like flipping coins. I will treat it as 1 is the head, 0 is the tail. And I keep flipping. So you actually produce a lot of 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1. And you just do a tally. How much times it will actually consider as a head, how many times is considered 0, and then you calculate, okay? And when you do that, you know actually will be around, okay? Let me get my code. Where's my flip coin book? Okay, I don't have the flip coin book here. The Monty Hall is here. Let's directly program the flip coin book from start. I'll do some optimization, okay? Oh, I can do without I can even do without a function because I may not need. So from random import random in, and I do the heads is equal to 0. So for I in range, let's do as much as possible, okay? If random in is 0 to 1 is equal to 1, then heads is equal to heads plus 1. One of the things here is, we didn't talk about it, but there's an operator can help you to get your code faster and simpler. Because this heads equal to heads plus 1, right? I can do this. Okay? Plus equal to means heads is equal to heads plus 1. Finally, that's it. I'll print heads. Save it to download. Okay, you see, upon 1 million times, I got around 500K times. Okay, but why is it not exactly 500K? Why is it not? You cannot guarantee that. Why? Because if you know that out of 1 million times is exactly 500K times, at the 49999 case, you know the next one is head or tail. You cannot be sure about that. So it's around there, but you cannot be exactly like that, okay? So, yeah, so what I want to prove is that's how we use the computer to prove something instead of pure mathematical proof. We do a lot of that in science, okay? The second type of proof is you don't know how many times you want to finish. Because the first time you want to finish 1,000 times is 1,000 times, 2,000 times is 2,000 times. But sometimes you don't. Why? We use another loop form called while. While is just now we actually already talked about. It's like if then else. If the condition is true, I do a body. Okay, the expression is the condition, and the body is what you want to repeat. Like this. What is it? My proposal. My sure win proposal. The answer is you do not know. But when the answer is not yes, I keep asking, will you marry me? And the answer is input yes or no. What happens next? I'll repeat if the answer is not yes. A bit psychic, right? Yeah. So I will repeat asking, will you marry me? Until you say yes. Until finally you say yes, maybe after 1 billion times you say yes, okay? Okay. So the condition for this is answer is not equal S. Anyone remember the movie Doctor Strange? The first one? The first one, what happened in the first one? How did Doctor Strange beat that super villain that is overpower him? I know. Sorry, should I leak the story? Anyway, Doctor Strange is like many years ago. If you didn't watch it, how he did it is he trapped in the time stone. He went there, he got killed. But then he said, I come here to bargain. And every time he got killed, loop again. Until the monster agreed to surrender. Okay, so and that is the same strategy here. But one thing here, you see this marriage proposal. What if the answer is yes instead of yes? A capital yes instead of a lowercase yes. What will happen? Sorry, please give me another answer that is yes. Okay, so this is a bit absurd, but then you have to be matching exactly the condition to break the loops or equal to the loop. So the capital letter yes doesn't make sense. How about this? What do you mean? Forever, right? Okay. One thing I want you to know that usually 99.999%, the condition after a while, you should be able to change it. This is not a good one unless you are doing something like operating system, like you want the system continue to move forever. Otherwise, 99.999%, your condition need have some freedom to change. There should be some variable that have some way to modify it, okay? And okay, let me ask you, what if I really fall into the so-called infinite loop? Wow, true, in, you will get an A, okay? Is it good? Okay, now it's continue printing. How do I stop the computer? Huh? How? Terminate the shell. You're so brutal. Let's say I'll continue to work. Yeah, it's good. It's good. You can terminate the shell. That is a secret. I think nowadays people don't know. Okay, in our era, people know. You can press Ctrl+C. Yeah, but it's memory. Okay, because what happened for Python is it actually will remember all the text because I print out so many. Okay, usually it will just Ctrl+C and you break it. Okay. This time I violate the memory. So yeah. So don't let that happen. Yeah. Yeah, I'm even more brutal. Okay. Yeah. And how about the other? What will you print? Nothing? Why nothing? There is a chance that when your condition don't even meet for the first time. Okay, because I said while A larger than 0. A is already 0, is not satisfied. Okay, so the condition is very, very important. There are 2 points here. First, you don't want a condition is forever unchanged. Second is the condition you need to make sure it can enter the first time. I mean, it's up to your designer. Of course, the third condition is make sure husband and wife communicate well. A programmer was walking out a door and his wife said, while you are out, buy some milk. And this husband never come back. Why? Because he's a programmer. Because the wife said, while you are out, buy milk. You can see this guy crazily buy milk outside because he's out. Okay? Yeah, so, but that is the computer, okay? Of course, human won't be like that. And yeah, so this is another way of doing the factorial by a while loop instead of a for loop. Because remember last time the for loop, the counter will increase by itself automatically or implicitly. This time I just use a while loop also can, okay? But of course, this is a different scenario. I know that when I enter the loop, I will loop it for n times. So this one, you just need to add a counter plus 1 there. So I don't go through this. But one small thing, hey, how come this guy is here? Can I? Yeah, how come I got? Okay, good. What does it talking about? The boundary condition for your loop to stop, especially when you use a while loop, you need to be careful. Okay. For example, just now for the factorial. Yeah. Okay. I equal to 5 is not handling. Why? You try to loop it, right? Loop n, counter. Counter will be 1, 2, 3, 4 looping. Will you stop when it's counter less than equal n, less than n, less than n minus 1, less than equal n plus 1, or what? Okay? What side at the boundary condition? Okay, so I don't have that. For example, this one, do you while not in the edge in front you stop, or while no, you are not in the edge stop? Because if you do the Foxy things, I forgot his name. While not edge currently, I run. Even the last step, I still run and run out of the cliff and fall down. Okay, but then how do we really judge that? I'm sorry. For this one, I will tell you. First, the best method is think carefully. And usually I don't. Sometimes you need to do trial and error. Okay, I don't want to say officially, but sometimes you need to think about the boundary condition carefully. And if you don't, test it out. Okay, the good friend for debugging is print it out. Of course, the second level is you can do while and while and while. Okay, for example, this code print you another Christmas tree, just use while loop. But I think we don't really use while loop that often until you go for some double loop or later in week 7 or 8 when we do 2-dimensional array. We need to do two-dimensional looping. We'll do that second while loop. Yeah. And one last thing is, usually when you are doing while loop and there is clearly a counter there you increment, it is actually better to convert it to a for loop. These two are similar, but the first one you use a while loop and you keep a counter. You increment yourself, which is okay. I'm saying it's okay. But if you do that, why don't you do a for loop? Okay, so they can be not mutually exclusive. You can code, for example, just now the factorial, you can code it in for loop, and you can also code it in while loop. Okay, but if you do some coding that you are not sure how many times it will end, definitely you need to use a while loop. So for example, this is the terminating condition. So let me ask you a question. Will you break the loop when the answer is yes or when the answer is not yes? English question, it's not a programming question. Will you break the loop when the answer is equal to yes or when the answer is not equal to yes? Okay, think about that. And the correct answer is You will break the loop when the answer is yes. On the other hand, you will be kept into the loop forever or your infinite vicious cycle when the yellow condition is correct. Okay? You're being kept there as far as the yellow condition is correct. So think about the condition is a trap. Whenever that's true, you are still trapped in the iterations. Okay? So the loop body will keep repeating if the condition is true. Otherwise, it will break the loop. Lastly, the third time. What is this so special? You are not very sure how many times it loops. I know that at most it runs n times. Why? For example, how do you check if a number n is a prime number? Oh, okay, let's do some assumption. Assume n is larger than 0, larger than 1. How do you check? And also n is an integer, okay? How do you check if n is a prime number? For example, I'll give you a number 91. How do you check? If you give you paper and pencil, okay? How do you check? How do you check? Well, that is actually the beginning of how do you design the algorithm, okay? You will check if 91 is divisible by 2, right? And then 3, and then 4, and so on, until if 91 is divisible by 90. What is the condition that 91 is a prime number, and what is the condition 91 is not a prime number? You have to write it down yourself as a pseudocode. If all the numbers from 2 to 90 are all not divisible, then 91 is a prime number, right? The other case is if any number between that is divisible, then it's not. So this is the code. Okay, so I will check if the number is prime or not. First, I said, oh, I assume it's not divisible by anyone. And then I will start looping. The for loop will loop all the numbers like 2, 3, 4, 5, 6, all the way to 90. If anyone here, so you can see the percentage here, the modulo. What does n modular I equal to 0 means in layman English? Sorry? Yeah, if n divided by I, the divisor, the remainder is 0. Can it be more simpler? Explain to a kindergarten kid. That means if n is divisible by I, then I will set the divisible by some number is true. I go through all the numbers, and if finally, after I finish all the numbers, if it's divisible by some numbers, that means is it a prime number or not? No, right? Then I return false because it's not a prime number. Otherwise, I return true. Okay? Let's optimize the code. This is too long and clumsy. I want to shorten it. And this is another thing I really want you to do. A lot of us, after we submit the code to Cosmology or do it, run it correctly, forget it, we are done. No, never do that. Because always you have some way to improve your code. For example, this final yellow box is very clumsy. And you can actually reduce it to return not divisible. Why? Think about it. If divisible is true, you return false. If divisible is false, you return true. Is it okay? Am I saying something making sense? It's like magic charms, right? So if divisible is true, you return false. If divisible is true, so you can just return the opposite of divisible. Okay? So the first step, I can optimize it to be like that. Okay? Second step, do I have to go through all numbers from 2 to -1 if I find something divisible already? For example, how do I check the number 100 is divisible or not? It's fine or not? I check 100 divided by 2, already divisible. Do I have to check 3, 4, 5, 6 all the way to 99? No, because it already break the rules. It already 100 is already not prime because of 2. So I don't need to go through all this here. Instead of saying that, I can return false already, like this. What does it mean by return false? Return false means at the return, I already break the whole function. I don't continue anything. It's like abort ship, okay? Everything run, so the whole function will finish and directly return false. And lastly, is the divisible by something important anymore? I'm not going to change it anyway. So I can directly return false at the end, right? Yeah, okay. So I can make the code like that. Do you think is it the ultimate code? Any more thing to improve? Yes, you still have a lot of things to improve. Okay, think about it. This code still have a lot of things to improve. If you write this code to check a prime number, whatever, for commercial use, sorry, you are not qualified, okay? Think about that. For example, do we need to go all the way to n-1? Do we need to go through all the even numbers and this and that? Okay, think about all this. Think about how do you save the computational power by checking this. I'm not going to tell you. You're going to think about it, okay? I keep you in suspense, and there's 3 types of loops. Why we say that is because for this one, we can skip any time when we already find the answer that the number is not a prime number. Okay, I only need to check if it's a prime number when I make sure every numbers between them is not divisible. Otherwise, if I find any divisible, I can just return it. Okay? Yeah. Okay. Another quiz. Can you get out your phone? This one is easier, don't worry. Hey, where's my... Yeah, repetition, okay? Okay, this one is easier. And then we have a coffee break. Anyone too far away cannot scan it? Okay, 10 more seconds. 9. So I'm doing a loop. 8, 7, 6, 5, 4. Okay, let's start. This is easier, okay? So let's see who is faster. If I want to print a star n times, how do I fill in the blanks? I want exactly n times. Okay. Ooh, good job. Okay, 80% of you got it right. How many times does the first case do? n-1 because it's 0 to n-2 only. And the second one, also n-1. Actually, basically, you can sense this. The difference between the two numbers is the number of times it will loop. Is it okay? So that's why all of them is less than 10 times. Good job. Who is the first? Is it Jason again? Oh, Jason, keep on. Oh, it's par. Okay, so let's see. Now I want to compute the result of A times B by adding it n times, okay? You know how to do multiplication? Instead of A 3 times 4, I do 3 plus 3 plus 3 4 times. How do I fill in the expressions? So I input A, I input B. I have an accumulator answer. So which one is the correct answer? This is a bit harder, right? Hey. Wow. Okay. I don't know because it's maybe faster. Why is this C the correct answer? The last one you already have an A, and then you still need to add A plus 1 time of B. So you are actually, the last answer, you are actually doing A times B plus 2. Okay? Oh, no, sorry, B times A plus 2, sorry, B times A plus 2. And the other one is this one. Actually, why is this wrong? Why is the first one wrong? I have A, and then I add A minus 1 time of B1. Why is it wrong? That is the terrible thing about programming. This answer of the first one, sometimes right, sometimes wrong. Why? Because if A is 0, is wrong, it will return B or return A, okay, directly. So that's why it's totally wrong. It's wrong when it's one of them is 0. So sometimes right, sometimes wrong. It's only this one is right. Okay. Jason come up. Okay, next one. If I want to compute the integer sum of 1 to n, which types of loop do I use? Okay, the 3 types of loop, which types do I use? For loops only, while loops only, or I can use for loop or while loops, or none of the above. Hey, good job. Okay, for loop is definitely right. Actually, if you use while loop, you increase the counter. So for the first type of loops that you actually know how many, you can use both. Okay, wow. Now, okay, now it's starting to be like more applicational question. You know all the password checker, right? You require you to have these crazy rules. I must have 1 numbers. I have a 1 capital number, capital letter. I have some crazy sign. But let's do it simpler. I give you a string of a password. I need to make sure at least one of the number, one of the character is a number. Which type of loop should I use? Okay. Oh, you have a limit of n because if you have a password, before you start, you know how many of them you need to loop through. Okay, so it's more technically belongs to the third one rather than the second one. I know that some of you may have this confusion. So I don't know how many times, but you know the maximum number of time when you enter the loop. That's what I call n times. Last question, is it? I think it's last question. Now assume that I already give you the prime numbers. This is difficult. Huh? This is the P level 3. Okay, P we have 3 levels, 1, 2, 3. Now I already give you a number. I give you a function that you can check whether a number is prime or not. And then you can enter another number. I want you to find the smallest prime number after n. So for the 3 types of loop, which one will you use? Hey. Oh, good job. How do you find it? The very simple way is because I know that I want to find a number larger than n. So I can start with n plus 1. I check whether n plus 1 is the right prime number. If not, I go to another one. If not, I go to another one until I find a prime number and I stop. So that's exactly the second type of loop. Good job for this. Okay, thank you. And who is the winner? Yeah, Jason again. I need to treat you a coffee, okay? Who is Jason? Later you come up, huh? Okay, thank you. That's most of it. So before that, if you can get 1 and 2 right, and 3 to 5, probably you can do the loop, okay? When to use for and when to use while. For is you know how many times, okay? And then while is you don't know how many times. I think that's basically it. And lastly, I will talk about the break and continue next time, I think, because it's time running out, because I want to end this. I'll do this later because I want to show the Monty Hall problem, okay? The Monty Hall problem is just not a program. What that guy did in the lecture is he used complicated math to prove it. But I don't want, my math is just bad. Okay, I admit it, okay? So what I did is, I write a program for that. I write a program just randomly, Monty Hall, yeah. Open with idle. Okay, this code is I randomly generate. Don't worry, I'll post it in the course. Actually, it should be on the course module. You can find it. I randomly run the experiment 10 million times, whatever you call it. I run the whole things. And what I do is I let the user to change or not to change. So where's the mark? So I will import a switch. If the switch is true, I mean the user switch. If the user switch is false, the user won't switch. It's actually in the code. If switch, I switch whatever, then I run it. Upon 100K times, if he doesn't switch, his chance of winning is about 1/3. And if he switch, his chance of winning is 67. I don't need the math. Is it good? I don't care about the proof. And I just need to run this, and I can tell you exactly the same results. Okay? So that's a good thing about programming. And lastly, let me give you this poem. Get ready to give it to your girlfriend or boyfriend, this poem of love. What is this? Let me explain that. You are my everything. Everything I said is true. And you are my everything. You equal to my everything. And my mind is all containing about you. And then I didn't have an if because my love is unconditional. And lastly, my love is internal because it's an infinite loops. Lastly, I didn't put a return. I don't ask for any. Okay, so you can give it to your girlfriend. Okay, thank you. That's it. That's all for today. Yeah. And wow, okay, thank you. Yeah. Any questions? Oh, okay, no more. I think you guys are too busy, okay? But if you have questions, please post in the post everywhere. I can answer it next week. Okay, thank you. That's all for today. Let me stop it first.